happens if we assume that M is true on the one hand or M is false on the other one. So, and this is an or statement. So true or true, that's line 1, and under the or we discovered that it's what? True. But now let's suppose that M is false. True or false, that's line 2. And if we look under the or, we see that that's also true. So we know that this thing is true, even though we didn't know what M was. Does everybody got that? So, so this is going to be true. So I'm going to just drop stuff down. Or, and this is true, and, so let's calculate this. True and false is what? False, okay? So here we are, we got this or this, and true and false is what? False. So what we end up with is this unknown or false. Well, this unknown could be true or it could be false. Let's think about what happens in either case, okay? True or false is what? True. And false or false is false. So depending on whether we assumed L is true or L is false, we get different results. And so when we get different results, what do we say?
Unknown.
Unknown. Okay, so the final answer here would be unknown. Okay, if you got true over true, you would say, hey, it's always going to be true. If you got false over false, you could say it's always going to be false. Everybody understand that? Okay. Now, let me say one thing, and that is, you might be calculating some big old problem. You get one part that's unknown, right? Don't stop there. Just because part of it's unknown doesn't mean that the whole thing is necessarily unknown. Does everybody understand that? So, like if you had false, then an unknown, and then it's part of some big expression, well, this thing is, wait, what did this example work? False, then false, then true, false. No, what I meant was this. Suppose that you've got this part is unknown and now you've got some big expression over here, blah, 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 blah. Well, just because this part is unknown doesn't mean that you can't know the answer, right? Because if the antecedent ends up being false, it doesn't matter what that is, the whole thing will be true, okay? So just don't stop just because you get an interim part that's unknown. Does everybody understand what I'm saying? Okay, just keep assuming it's true or it's false and keep going. Did I do problem number 5? No. Let me do number 5 because it illustrates an important point. Number 5, I have not and if and only if n, and then it says then L. Okay. So n is unknown. Okay. So we have not an unknown, and it could be true or it could be false. Right like this. If and only if. Now here's the thing. This n and that n are the same, so wherever we're assuming n is true, we have to assume that that n is true. Does everybody understand that? So we put true over false. Okay. Then this, then L. Okay. So let's calculate this. Well, we got to negate this. So when we assume n is true, it gets negated, so it's false if and only if, and this n would be true. False if and only if, true is what? False, okay? If we assume n is false and negate it, we end up with true. true, so we have true if and only if, false, true if and only if false, which is what? False. So what did we discover? This is false, this part, then this unknown, okay? So what I wanted to point out is that this n and that n, you're supposed to assume that they are the same n. So if you're assuming that this n is true, you have to assume that n is true. Does everybody understand that? Okay. Now, of course, we ended up negating this n, so it flipped it, but okay. So here we are, false, then L, and L could be true or it could be false. Let's think about what happens in either case. False, then true is, well, that is true. False, then false, that is true. So what did we discover about this? This statement is, yeah, so we're going to say that this one is true. And it's kind of amazing that we can say that because we don't know any of the values of the parts, but we know it doesn't matter how you substitute in, it's going to end up being true. Everybody got that? Okay. But the big thing I wanted to say is, hey, if you have an n in one place and you're assuming it's true, wherever else you have that n, you have to assume it's true there too. So everybody got that? Okay. All right. Any questions on that 3.2 where you're dealing with some unknowns? There will be some problems where it's all knowns, and then there will be some problems where there's an unknown or two thrown in, and you tell me if it's true or false, if you can determine that. Or if you can't, you say, hey, this one is unknown. Okay? All right, so that takes me to 3.3. And now 3.3 is categorically different because in 3.3, we're saying we don't know what the truth values of these statements are, but we want to know when the statement is true or false, so we have to go through all the possible combinations of truth values. Okay? So let me do problem 7. I don't think we've done this. Okay, so 7 has 3 different statement constants, H, I, and J. Okay, and what that means then for us is that we're going to need 8 rows to exhaust all the possible combinations. Remember, it's 2 to the n, where n is the number of statement constants. 1, 2, 3, so it's 2 to the third, which is 2 times 2 times 2, which is 8. So we need 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. And remember, our convention is to list the statement constants in alphabetical order. And start with the rows rightmost and rotate between true and false until you run out of lines. True, false, true, false, true, false, true, false. As you move over to the next column, you double the pattern. So we have true, true, and then false, false, true, true, false, false. And when we move over, we double again. So now we have 4 trues and then 4 falses. If you follow that simple pattern of filling this in, that gets you all the possible truth combinations. Okay, so now what are we figuring out? We have H, then I, then J. H, then I, then J. And let me see, there's a close if and only if, close if and only if, not H or, and then I, then J. Okay, so we're going to calculate it for each one of these lines. And on each one of these lines, we're making different assumptions. On line 1, we're assuming H is true, I is true, and J is true. See, true, true, true. Okay, so I have to work from innermost brackets outward. So here we have true, then true, which is what? True. So let me get rid of that because that was the interim. And this H is true, so I have true, then true, which is what? True. So cross out that. Now I got to figure out this, and then the final operation is the if and only if. This is my main logical operator. Okay. I is true, J is true, so true, then true is true. H is true, so not H is false. So we have false or true, which is true. Okay. So this side of the biconditional is true on line 1, and this side is true on line 1, so we end up with true, if and only if true, which is true. Okay, so we've solved that expression for interpretation number 1. Well, now we need to do the same sort of thing with all the rests. Okay, so let's I then J. On line 2, I is true, and J is false. So we have true, then false, which is false, okay? And H on this line is true, so I end up with true, then false, which is false, okay? So the left side of the biconditional is false. Let's calculate the right side. I and J, true, then false is false, okay? H is true, so not H makes it false. So false or false, which is, why did I write true? False or false is false. So the final calculation I have to do is false if and only if false, which is true, okay? So we've solved it for lines